So today, 1.2, we're going to continue our exploration in chapter 1, where now not only have we identified individuals and the variables and the different types, now we want to know how do we actually take that data and look at it and start to analyze it and make decisions based on what information that we have collected. So today, 1.2 is going to focus on categorical pieces of information. So, we're going to talk about analyzing categorical data. That's all we're going to talk about. Okay? So we're going to focus on this one. In 1.3, then we're going to start to take a look at quantitative. And actually, 1.3, 1.4, 1.5, because quantitative, since it's numbers, has a lot more to it. But when we go and analyze categorical pieces of information, lots of times what will happen is we'll be given the information in what's called a frequency table. Basically, it's going to be a table of information that tells us how many people do that, like how many people have blue eyes, and how many people have green eyes, and how many people have brown eyes, okay? Or what percent have that. So we'll get it as a table, as counts or percents. Once we get that table, we want to see what it looks like. So the two ways that categorical data is represented is by doing pie charts or pie graphs, sometimes referred to, and bar graphs. So some of you might be going, well, wait a minute, didn't we do some of this in junior high? The answer is yeah. But we still go back and visit it because we're going to take it to even more and more extremes in this course. Okay. So today we're going to start off by just doing some pie graphs and some bar charts. So go ahead and flip to the next page. And we're going to take a look at a couple examples when doing this. So the first example says the article, "So Close Yet So Far, Predictors of Attrition in College Seniors." J. College Students Development from a 1998 article examined the reasons that college seniors leave college programs before graduating. Okay? 42 college seniors at a large public university who dropped out prior to graduation were interviewed and asked the main reason for discontinuing enrollment at the university. Data consistent with that given in the article is summarized in the accompanying frequency distribution. So here is basically some categorical data organized for you in kind of like what we call a frequency table, but I sometimes look at it kind of like a spreadsheet. So here we have the reasons for leaving and the frequency. How many students gave that as the reason for leaving the college? So the first question, or the first part says, convert all the counts into percentages. Then display the data in a pie chart. So the first thing I need to do is change these counts to percents. So they give us the frequency, so we need to change these to percents. So, in order to change them to percents, what do I first need? I'm sorry? Well, calculator may help too.
The total.
I need the total, don't I? I'm not given the total because percents are part of the whole. So I need to figure out how many students. Did they tell me in the article how many there were?
Yeah.
42. So hopefully when I did this table I did it right. So I'll just do a quick check. 10, 12, 23, and another 13 make 36. 6 more makes 42. So now I need to basically take each of these numbers and divide them by 42. And change all of these to percents. Okay? So, if you have your calculator, I'll take a second and at least load my calculator up. I'll do a couple of them, and if you don't mind, I'll grab my notes and write up all the percentages. Now you might be going, well, how far do I need to go percentage-wise? Okay? It all depends. On this one, I might either round to the nearest percent or I'm either going to go to the nearest tenth. So, wow, that's an interesting graph. So I'm just going to clear this screen. Actually, I might have to exit out here, so I'm going to quit. We don't need a bar graph. Wow, that's really big. So I just want to shrink it a little bit. So the first one was 7 out of 42. So start off here, I go 7 divided by 42. So about 16.7%. Remember, percentage moved the decimal over 2 spots. Then I had 3 divided by 42. So about 7.1%. I'm going to note those right now. 16.7%, 7.1%. And I want to do that for each and every one of them. For time's sake, are you okay if I give you the rest of the percentages? Yeah. It's just a lot of, sometimes what you'll notice here at the beginning, especially chapter 1, there's a lot of busy work. You know, you're just doing a lot of basic arithmetic. In case if you're having a hard time reading these percentages, I'll state them out again. Okay. So 16.7%, 7.1 were the first two I did. Need a break is 4.9%. Economic reasons, 26.2%. Okay. Family responsibilities, 9.5%. To attend another school, 21.4%. Personal problems, 7.1%. And all other reasons, 7.1%. So, we got them all converted into percentages. Then the next thing it asks us to do is display the data in a pie chart. So, a pie chart, sometimes otherwise known as, sometimes another name will be a pie graph. Okay? Pie chart, think of a piece of pie. You've seen these before, big circle. And then we want to make wedges for all of the different reasons. And the wedge should be the percentage of that circle, or a rough percentage of it. Now this is where it becomes kind of challenging because we have, 2, 4, 6, 8 wedges that we have to put together. We want to make sure that they represent their percentage. Doesn't have to be exact, but it should be still a relatively nice picture. So what I like to tend to do is I look at ones and I think of, my circle, and I say, all right, if I divide the circle in half, that's 50%. If I divide it in half again, I'll get 25%. So I know a quarter of the circle is 25%. So I'm going to look at percentages that are close to 25%. Well, economic reason is 26.2. So what I like to do is say, all right, 26.2, that's a little bit more than a quarter of the circle. So here's my middle maybe, and I'm going to go just a tiny bit more than a quarter of the circle. Now, what I also am going to do is I'm going to note which one that represents. So I'm just going to put the initials right here, ER, and I'm going to write right here, ER. So I know that's because of economic reasons. So as I continue on, I want to make sure that I get all of the data represented. So now I'm thinking I got 26.2. If I combine it with 21.4, that's almost 50% of the circle, or half the circle. So instead of going just straight across, I'm going to go just a little bit less. Okay. Need to attend another school. So I might go AS for attend another school. I'm going to note that one. So now I got to start to put a few more of these together. Well, if I look at, say, academic problems and family responsibilities, those add up to just a little bit more than 25%. So I kind of like to chunk it in 25%. So if I go from a line here and go straight like this, and just maybe a tad bit more, I'm going to now take academic problems and family responsibilities and put those two together, okay? For my roughly 20 was about 26%. So this one here is about 16.7 roughly. So I'll go AP for academic problems, not Adrian Peterson. Okay. And 9.5% family responsibilities, FR, family responsibilities. Now, I still have 1, 2, 3, 4, and notice how 7, 7, 7, and 4, or about 5, add up to about 26. Notice how this is probably about a tad more than a quarter of the circle. I got to divide this into 4 sections. So the smallest one is need a break, so only 5%, so I only want about a fifth of this. So maybe I'll just go right about here, which is the smallest one, need a break, NB. Now all the rest of them are the same, so I'm going to divide this section into 3 equal pieces. So I'll try to divide it. Oh, that's funny. I know I hit blue there, but it didn't take it. Oh, that's why. There we go. So 1/3 and 1. Okay. So try to divide those in equal sections. Not quite, but close enough. So poor advising or teaching. So what do you want to use for that one? PA. So poor advising. PP for personal problems. Oh, wow. That just sounded wrong. And I can actually write other. I can probably fit that in. And I got my display. Now I'll tell you right now, most times in this course, I know we did one by hand and showed you how we do one. Most of the time, if I'm going to display categorical data, I like to tend to use bar charts more than pie graphs, but I still wanted you to see one. Lots of times they'll give you pie graphs or pie charts and ask you to answer questions from it. Okay? All right, any questions with this one right here? I'm okay, you're okay? All right, let's take a look at the second one. The second one is kind of humorous because even though I know I've used this problem for probably like 4 or 5 years, but you'll see how the data is probably a little bit even out of date. So, on the second one here, it says, here are the percents of 15 to 18-year-olds who own the following personal media devices, according to the Kaiser Family Foundation. So here's the device, okay, and percent who own. Part of the reason why I think this is outdated, MP3 players, aren't those usually kind of like now built-in cell phones these days? Handheld video games, I still occasionally will see kids with those. Most of the time though, it's in the junior highs and the high school. iPads, definitely common. Laptops, common. Boy, if I wrote up Chromebooks up here, what would the percentage be? Hopefully 100%. I know we got an email saying only about 90% of students have their Chromebooks right now. All right, what's nice about this one is they give us the percentage that own. So here, question A says, make a well-labeled bar graph to display your data. Describe what you see. So we got a couple things that we need to do here. First of all, I need to make my bar graph. So a bar graph, when we make a bar graph, the first thing we want to do is make an X and Y axis. Now with bar graphs, technically, you can flip the X and Y axis around. I tend to like to have whatever the individuals are on the X-axis, and the Y-axis represent like the frequency, or in our case, the percent. So it does say well labeled, okay? So down here I'm going to write device. Notice I'm even leaving space here because I'm going to label each device by a bar. And then my y-axis is representing the percent who own. So what I'm now going to do is make a bar for each of them. I'm going to look at my percentages and say, all right, well, I almost get to 100%, so I might count by 20s here. 20, 40, 60, 80, 100. I want to label my axis here. And now I want to draw a bar for each one. So here I'm going to start with cell phone, CP. And I want to go up to 85%. You guys want me to be colorful? All right. So for the next one, I'll switch colors and go MP3 player. So MP3, go up to 83, so it's just a little bit less. 85, handheld video game. HVG. 41%. iPad, well I'm just going to write that as iPad. That's easy enough to, so an iPad was 36%. And last but not least, laptop. So I might go LT, 28%. Now I should try to make a title for this. So I might say devices owned by, and I believe it was what, 15 to 18-year-olds? So I know what my graph actually represents. Lunchtime? No. I know we eat last lunch now. Now it also asks you to describe what you see. I'll use brown for that one. So the describe what you see. So when we look at the graph, we just want to write a sentence or two about what the graph is telling us. So what do students own the most? Cell phones and the MP3 players. It's not only the most, but it's close, it's somewhat close to 100%. They're both in the 80%. So I might say something like this. The majority, so majority, if you remember back in the days, means more than 50%. So I could maybe even say the vast majority of 15 to 18-year-olds own a cell phone and a MP3 player. Then I might say now the other three are all under 50%. So I might say less than half of them, well, I wrote half instead of half, of them own a handheld video game, iPad, or laptop. So when you're asked to describe any time in statistics, you want to make sure that we're talking about all the data and we want to make sure what we state is factually correct. Majority is more than 50%? Yep. Okay. We include the first two, the last three we have in the second sentence, and it's less than half. The last question here is an important one. By the way, am I going too fast? Does anyone still need a second or two? Because I know sometimes I go too fast. This last question is very important because you might be saying, well, can I use a pie graph anytime? Can I use a bar graph anytime? What are the advantages or disadvantages between them? Bar graphs, in essence, can basically be used almost any time dealing with categorical data. But pie charts, not necessarily. And this is why this question's being asked. Would it be appropriate to make a pie chart for these data?
You just said categorical data.
Categorical data, yes.
Okay.
Right.
Isn't quantitative one of numbers?
Right. So if I look at this, the data being collected, I'm asking, do you own a cell phone? And you answer it yes or no. Okay, because I'm putting you, either you own it or you don't. I'm not saying how much you paid for your cell phone. If I ask, quantitative might be the cost of cell phones, $74, $85, $96. Okay? So this is why this is categorical, because either you own it or you don't. Either you have an MP3 player or you don't. Okay? All right, so going back to here, would it be appropriate to make a pie chart for these data? Why? Yeah, you are correct. The answer is no. Okay. What's interesting about these percentages? Oh, go ahead, Nicholas.
When you use a pie chart, it's mostly ideal for the data just to go up to 100%, but here you have like two percentages that are 80 and stuff like that.
Okay. So all of these percentages, when we're doing categorical data and you want to do a pie chart, it has to be on a single individual or a single piece of data. Okay. Okay. Or in this case, one piece of information we did was cell phone. Okay. Well, either you own a cell phone or you don't. Okay. So if I said didn't own a cell phone, I could make a pie chart for that because 85% do, 15% don't. I could have a pie chart for that. But we have several different categories, and the individual could fall into multiple categories. Do you own a cell phone and an MP3 player? Some people do that? How many of you own more than one of these devices? Okay. You think, look at how many hands we have up there. Okay? Many of you do. Okay? So you fall in, you're going to get double counted, triple counted, quadruple counted. So it's not going to be appropriate to do a pie chart. Couple reasons why. Well, the percentages add to more than 100%. Okay? And a pie chart, it has to add up to 100%. Okay? Plus, or the reason why they're adding up to 100%, more than 100%, is the data collected is not a part of a single unit or a single individual, but multiple categories. Okay? So the data collected is not on one single piece of information, but many pieces. If you wanted to do a pie chart for this data, you would do one for each device. Hopefully that makes sense what I'm saying. Like for instance, if I did cell phone, our pie chart might look something like this. 85% own, 15% do not own. And it would only be on the cell phone. So you couldn't do a pie chart that has all the data in it.